My name is Cunningham. I'm here to talk about Hipara. Hipara is an open source endpoint detect and response platform where we use Python/Django for a web front end console and have developed on the Windows platform a client that is able to help you detect and respond to threats on your network. We started off by using Yara and GrrCON. So Yara is an industry, or has become an industry framework as a way to develop a signature against, some malware or a malicious file that you're looking at. And then GrrCON was produced and still is by Google. Stands for GrrCON Rapid Response. The reason that we created Hipara was because companies typically have a number of sharing partners that they share intelligence with. Anyone here part of an ISAC organization? We got one, two, all right, 3, 4 more, perfect. So in a lot of ISACs, what I see in my day job is not only IOCs and malware samples sent back and forth, but Yara signatures. And the big problem that we had is with Yara signatures, we were only able to deploy them to VirusTotal to be able to collect more malware samples that we are interested in, or we would use them post-breach during our analysis of a box. There was no way to use those Yara signatures for detection purposes on the host. A few vendors today now support it in a limited capacity, but obviously if I'm here standing today talking about this, I think that we're the best. We also have created modules, and we'll continue to create modules that go after specific attacker TTPs. We'll talk about those specific TTP modules here in a moment. And then again, we're open source, so we stand by the technology that we develop. There's no secret sauce, so to speak of. So we're able to tell everyone what we're doing. You guys can go in, take a look at the code yourself, review it, hopefully make it better. But no secrets there. Up here I've got an example of a Yara signature. This Yara signature is broken down into 3 main pieces. The meta field, which just gives a general description, or it's very arbitrary, whatever you want to write there. You can say, I'm looking for a certain malware family, who it's written by, anything else. The strings portion is the parts in the code that you can actually see by running something like the command strings, which is very common on Linux. And then the condition just says what parts of this rule need to be in place in order for us to alert and detect on. At the bottom there, all that it's saying is that it needs to be a portable executable file, which in the Windows world typically boils down to AXEs and DLL files. And then this Yara rule wants to see both lines S1 and S2 in combination with identifying that it's an executable file, and then it will alert. Now, if you're not in an ISAC or some sort of sharing organization, there are some really amazing repositories out there where you can go and get Yara signatures. One of my absolute favorites is an open community. I say open. It's closed. All you have to do is apply to get in. It's free, and it's called the Yara Exchange List. They just want to make sure that you're not a malicious person. You're not one of the actors trying to take a look at, what signatures catch their malware. But other than that, just go ahead and apply. You'll get in. And then there's a couple Git repos where there's absolutely hundreds, and I think the second one has over 1,000 Yara signatures, and it's updated on a pretty frequent basis. I'll make sure that with the GrrCON staff that these links are on the website so that you can follow up with them afterwards. So we're going to talk about what Hipara is really doing for you on the endpoint and how it's going after your adversaries and your attackers. This model right here was created by David Bianco, a coworker. Him and I both worked at General Electric together. He went on to publish this and describe what it takes to really cause an adversary some pain. All right, so trying to catch a malware by using an MD5 or some kind of checksum is at the very bottom. If you're just building up this huge long list of things that you don't want to see in your environment, you're going to drive yourself crazy before you drive the adversary and cause them any sort of pain. As you start moving up, IP addresses, you know, there are a finite number of IP addresses out there, although that number is fairly large. And they're exchanged quite often depending upon, well, for threat actors, they're able to dump them quite quickly as they move their delivery mechanisms or their C2s. So still, you can cause them a little bit of pain by tracking that, but again, it's still going to be up to you carrying the burden of that. With domain names, it's very much the same. Network and host artifacts are different. So we're talking about file names, we're talking about user agent strings, any kind of oddities in the HTTP header caused by a backdoor. These tend to persist quite a bit longer and aren't changed by that adversaries as often. So Zeus, you know, for the longest time would do an HTTP post using /gate.php. And I don't know off the top of my head how long that persisted, but I want to say it was at least 2 years. Tools. This is where Yara really starts to shine. You're able to describe what tool you're going after, what tool you're trying to stop with the Yara signature. And this is what Hipara uses when it is checking every single file that is opened by your end users as they're opening it. And TTPs. Now this one is tough both for defenders and for actors. So when actors, you know, develop a TTP, which stands for tactics, techniques, and procedures, it's a certain way of them having to do something. Typically, like with any kind of pen tester, I won't say, you know, great pen testers, but with, you know, vulnerability assessments, you're going to start off with something easy like Nessus or some SQL scanner like SQL Mapper. And you can see that as part of their routine in each portion of it. That's not the greatest example of a TTP, but I hope it gives you the idea. It's what the adversary must do to accomplish their end goal. Without executing on their typical tactics, techniques, and procedures, they can't reach that end goal. So typically we're talking about, you know, exfiltration for, you know, maybe some state-sponsored attackers or even some cyber criminals. For ransomware, we're talking about they must encrypt files and scare the end user into paying that ransom. So our philosophy is to go after your bottom rung of the pyramid with Yara. So everything from tools on down. You can use Yara to describe the indicators of compromise and the maliciousness that you're going after. And you can respond to those by using the industry leaders of Google or GrrCON Rapid Response. It's really tough not to say Google Rapid Response, but they have on their main website detailing that's not the name of it. So trying to make sure I say that appropriately. And then our TTP modules. This is where things, in my opinion, get really, really cool. Our two TTP modules that have been developed and are stable today are the command line logging and anti-ransomware. So lastly, on the Yara portion for Hipara, we do scans of the full memory process for any open file handles or any open processes. We are in the kernel, so we get access to what we need to do. And then we have a disk scanner that not only scans files as they're accessed by the disk, but you can also schedule full disk scans. This comes in handy a lot when you need to answer to your executives. You know, say a semantic or a Kaspersky report comes out, and you need to answer to them, are we compromised with this? Take those Yara rules from the report if they're provided, or you can craft some your own, and then deploy it out to your entire enterprise and see if those attackers are on your network. You can very simply answer that by the end of the day. Then lastly, you're able to change up what kind of files that you want to scan. This is something I don't see with a lot of other solutions. Here, if you're concerned about web shells, you can configure Hipara to only look at .php or any kind of insert web programming language here. In our default, we look at executables, documents, text files, BATs, and INF files. So a lot of those can be looked at for your typical weaponized document. So with documents, it would be for weaponized documents in like a spear phishing attack. I mentioned the command line logging module. This is, in my opinion, one of the coolest pieces of research we've ever done. From memory, we look at a very specific data structure called command history that the research was done by the Volatility Project. And I would say that they are absolute experts at analyzing memory. We took the command structure that they were able to describe, we looked for that in memory, and then we send it off to your in-house SIM, be it an ELK stack, Splunk, or anything else that is able to receive our syslog or API calls. Some people have chosen in smaller organizations to review those commands on a daily basis. In this example, I pulled up just a list of commands that were run, and you could go through and check if your organization is small enough to see if these commands are valid. So I've got to stress how much that, post-breach, so once an actor gets onto your network, the vast majority of them are going to use the command line. It's one of the easiest, quickest ways to move around. Getting GUI tools is just not feasible. So it's going to be really, really hard to hide when your organization has this kind of visibility. The next TTP module that we're going to talk about is with ransomware. Not that you have to say if you've ever been hit with this, but anyone know of anyone that's been hit with this? All right, causes a lot of pain, a lot of pain. A guy named Patrick Wardle did some amazing research and put out on a blog just as open source research where we can actually tell if a process is attempting to write an encrypted file. Crypto ransomware attackers must encrypt files for them to hold your files hostage. There's no other way around it. Using Patrick Wardle's research, we were able to use 3 different algorithms that looks at a file as it's being written. So I'm going to take the example of just typical entropy. Even if you've ever run strings or opened up in a hex editor, something like a .doc or Excel file, even though it looks messy to us, according to Entropy, it's a very structured file format. There's not a high order of randomness to it. Once you encrypt a file or compress it, the entropy value goes way up because the randomness goes way up. That's why, that's how encryption works. That's how compression works. They try and take, repeated bits away, at least for compression. And from the example that I ran on a single file, the entropy goes from 1 to 9. A typical Word document was roughly around 5.5. After encryption, it went up to 7.7. So the numbers don't really mean too much, except for the fact that you see a large difference of 2.2 when, large being when you're only looking at values 1 through 9. So by using entropy, we're able to see that there's a huge difference in the randomness and the order of the file. Using the Monte Carlo and chi square algorithms, we're able to tell the difference between a compressed file and an encrypted file. After we tell that a process is attempting to write an encrypted file, we'll actually we'll look up that process and see if it's a trusted process by your organization. Maybe you send encrypted files and have to because you're part of a financial institution. So you need something like WinRAR or encrypted PDF capabilities. So you get to define that within Hipara, and we'll take a look, see if it's trusted by your organization or not. And if it's not, at this point in the stage, we see a process that is trying to write the john.dat.fun. That is the encrypted file right there that a ransomware family called Jester is attempting to write. So at first it opens the unencrypted file, copies the data over into an encrypted file, and then makes a request at the very end to delete the file. Right before the deletion and upon the write of the encrypted algorithm or of the encrypted file is when we're able to stop the process. We actually take a backup just in case and restore that backup in case we run into a race condition. So our deployment looks very much like your typical client server application. Like I mentioned, we have a Python/Django web server where you can take a look at all your alerts. The application looks like this, very simple. And if you go on our website, hipara.org, under the blog, we have a demo account that's set up that you can actually log into and take a look at what the web server looks like. And then very shortly, we'll also have an MSI package that you would be able to deploy within a virtual machine and test out to see whether or not Hipara is able to catch the files that you're defining are malicious. So as long as you have a YAR signature up on the web server that matches the file that you're going after, then it will and should work on your web server or on your virtual machine as well. Since we opened this up, we've gotten a ton of people messing around and uploading YAR signatures from various repos. That's actually how I came about knowing about this one and found out what a great resource it is. Also, in the architecture, I talk about sending logs to your in-house SIEM, like Splunk or Elk. We have a demo Splunk server set up that we'll be giving credentials out to shortly, where you can go and test this out. I've looked for a table, or I've looked for any commands that have been entered and want to present it as a table. And we're able to see what the process name is of the command, or what the parent process ID is of cmd.exe. And you can also see the commands that were issued. In a couple of these examples, we've got someone trying to run a crypto ransomware executable. The FLT-MC command, which is to load drivers, which is, could be used in loading a rootkit, and then pinging various IP addresses. Our development pipeline. We solicit feedback from the community quite heavily. This is a lot of the feedback that we've received so far. We're starting off with a hunt module where do many people here use EXIF tool to get metadata from a file? It can be used as one of the first steps in reverse engineering just to see what type of metadata or attributes are attached to a file. This has been incredibly helpful in the past in other scenarios in doing threat hunting. One of the common tactics we see with adversaries is that they try to mimic the names of various vendors such as Microsoft. With these logs being sent to your SIM, we're giving you the capability to go through those logs and see if there's any misspellings, if there's any foreign actor names that have created weaponized documents, or looking for any oddities. There's a great example of a weaponized document creator that was prolific for about 3 years, where the author name never changed. It was Trey De La. And if you ever saw that in your environment, you'd question why. So some of the thoughts that we've received from those in the community was, if you're able to get all the metadata from files into your in-house SIM, are you able to load up names, foreign names, if you're not an international company? I'm talking about, some smaller places, in there, and just see what pops. See if anything comes up in your research or in your search. With misspellings, you'd be able to use some very simple, autocorrect algorithms out there to see any oddities within your own environment. You can also compare file names and metadata. So if the file name says that it's an Adobe update, but the metadata says that it comes from Microsoft, that's a huge clue that that's not going to be legitimate. The system profiling, Intel Exchange, this I thought was one of the cooler ideas that we received. Anyone that wants to be able to create, generic profiles that says, alert me whenever Adobe writes an executable file. Let me know when there's an executable file running out of the temp directory. One customer wants to take all of their sandbox output, write generic rules based upon that, and feed it in. We thought this was an absolutely great idea. And so not only are we going to work on building that behavior-based searching into our tool, but we're going to work on building an Intel Exchange where people can trade these profiles back and forth. And contribute to the larger community. Right now, we're in a block all or block none. You get alerts when something malicious happens. A lot of people have asked for us to change it from, I have a high fidelity YAR signature that I've uploaded to my web server that's being deployed out to all my endpoints. That one I want to block. But I've got another lower fidelity one over here that I've just written. I don't know how well it works or if it's going to be noisy in my environment. Just alert me when that occurs. And then execution profiling. So taking a look at the way malware authors actually package up their malware or their shellcode. If there's any process injection happening or process hollowing, we're building on that. So we're looking for feedback from the community in our development pipeline and actually making that, a core part of our tenement. All right, we're going to explore the user interface just a little bit more so that you can get kind of a feel of exactly what it is you can do with this. And I got to remind you, this is still in its early stages. We are roughly at 1.0, and so we're developing further. But within the user interface, when you receive alerts like this, you're able to investigate further with the host by us integrating with GrrCON. All right. And you can request that a live response be made. A live response being collecting log data, memory capture, and the file in question from the endpoint client. You can mark it as a true and false positive. We're going to take this information and help evaluate your YAR signatures, letting you know which ones are higher fidelity or lower fidelity, which ones are causing false positives. And then anything that you can do within the user interface, you can do with the API as well. If you want to upload, like I mentioned, there's 1,000 YAR rules in that one GitHub repository. That's going to stink going through the interface trying to upload them all. But you can do this purely by scripting it out. You can also take a look on your deployment status for each signature, seeing which ones are deployed to the host, which ones are pending approval, nope, that was the end of my sentence there. All right. All right. So then lastly, what I'm here today looking for is help from the community. Who would sign up to actually test this out? Who would actually sign up and deploy it within their enterprise? Give it a go. See if it's able to help defend against the adversaries that you, your industry, and your company are trying to fight. And then if we've got anyone really ambitious, we've got a 4-man development team, but we could always use another hand. So at this time, I'd like to take questions. Yeah, thanks, Dave. So the question being, what kind of platforms are we on right now? Currently, we're only on the Windows platform because, as you mentioned, and as I mentioned earlier, writing to be able to interact in kernel land takes quite a bit of time. So we've got to replicate the same process throughout Linux, throughout Mac, etc. Having gone through the process once already, knowing what needs to be done to push it further is going to make it that much faster, though. Question was, does Yara need to be installed on all your machines? Hipara is an MSI package that you're able to deploy. So just like any kind of Windows program with an installer. So our package comes with Yara and enables it to be able to run and scan the files that are being accessed by your endpoints. So the MSI package does that for you. Yes. What kind of performance hit do we see in endpoints was the question. Right now, we're seeing less than 3% CPU utilization, and generally speaking, it's around 1. When we do the full disk scan, so you're scanning the entire disk. At the beginning, yeah, we were seeing 99% utilization, so we just got to throttle that down. We're making it configurable to 30%, where people can choose to make it even lower if they want. So we're going to actually make that defined within the config file itself. All right. Well, thank you very much. Please come see me if you'd like to test it out or deploy it within your network. We're really big on community feedback, as I said. So thank you.